Welcome to AI Frontiers. Today, we're exploring the world of computer vision, focusing on a collection of research papers submitted on August 15, 2025. Get ready for Eyes of AI, Computer Vision Today. This presentation will unveil the future of sight by journeying through the latest breakthroughs in computer vision. We'll discover the dominant research themes shaping the field, examine key findings and their potential impact, and highlight seminal papers and future research directions. Computer vision empowers machines to interpret visual information, extracting meaningful insights from images and videos. It's transforming industries from manufacturing to healthcare, powering applications like self-driving cars and augmented reality. One major research theme is attention mechanisms. These mechanisms allow AI to selectively focus on key image regions, improving object detection accuracy in complex scenes. This enhances the performance of various vision tasks by prioritizing relevant features. One study focused on using attention to filter out noise and improve image clarity. The technical concept behind attention mechanisms mimics human visual attention by weighting different parts of the input. This allows the model to focus on the most relevant features, improving accuracy and efficiency in various tasks. It's essential for handling complex and cluttered scenes. Training models with limited labeled data is a key challenge in computer vision. Therefore, low-resource learning is a major research theme. Transfer learning and few-shot learning are gaining traction. These techniques are critical for medical image analysis and specialized domains, and researchers are exploring new training strategies for scarce data environments. Another research theme is multi-modal learning, which integrates visual information with text or audio for comprehensive understanding. This improves video captioning and scene understanding tasks, creating richer and more descriptive representations. It enables more nuanced and contextualized AI. Key findings in visual intelligence include significant improvement in object detection using novel attention mechanisms. State-of-the-art few-shot learning is being achieved with limited training data. Multimodal learning enhances video understanding accuracy. Moreover, gender biases have been identified in certain Generative Adversarial Network, or GAN, architectures. New architectures also require less training data. Core techniques in computer vision include Convolutional Neural Networks, or CNNs, for automatic feature learning. Transformer networks are used for modeling long-range dependencies. Generative Adversarial Networks, or GANs, are used for generating synthetic images. Data augmentation increases data diversity and prevents overfitting. Our first selected research paper is IllumaNet, a deep learning approach for low-light image enhancement, by Park et al., 2025. The objective is to enhance image quality in low-light conditions. The method involves a deep convolutional neural network called IllumaNet. Findings show that IllumaNet outperforms existing methods in visual quality and metrics. The significance lies in its potential to improve vision systems in challenging lighting. Next, we examine the paper, Crossview, a multi-view learning framework for person re-identification, by Chen et al., 2025. The objective is to match individuals across different camera views. The method employs a multi-view learning framework called Crossview. The findings show state-of-the-art performance on benchmark datasets. The significance of this work improves video surveillance and security applications. Our third selected paper is GAN Shield, Defending Against GAN-Based Adversarial Attacks on Image Classification, by Kim et al., 2025. The objective is to defend against Generative Adversarial Network, or GAN-based adversarial attacks. The method uses an adversarial detector and image purifier called GAN Shield. The findings show improved robustness of image classification models. The significance of this work lies in it enhancing security and reliability of vision systems. Future directions in computer vision include improving the interpretability of deep learning models, developing robust models for noisy or incomplete data, and creating energy-efficient and computationally lightweight models. Addressing and mitigating gender and racial biases is also a crucial area of focus. The synthesis for this presentation was created using AI tools including GPT, Google using Model Models, Gemini 2.0 Flash, and TTS synthesis using Google and image generation using Grok. It was reviewed by a human expert for accuracy and clarity. Potential oversights may exist, but all references are provided. Subscribe to AI Frontiers on YouTube to get the latest AI research and insights. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.